My name is Mike Coleman, and so what we want to do now, I'm from Docker, I'm a technical evangelist, and what I want to talk about now is a little bit of a deep dive into the latest version of Docker. Docker 1.12 was shipped about 6 weeks ago, roughly, and it represents probably the biggest upgrade to the project in its history, because we took some technologies that had sort of existed as a standalone, and we integrated them into the core engine. So the Docker engine offers a whole bunch of things now that you really do need to deploy your applications at scale in production. So we used to have a standalone offering, and we still do actually, I shouldn't say used to. We had something called Docker Swarm, and Docker Swarm ran as a container on a node, and you would run it, and that would allow you to do what we call orchestration. And for the simplification of this discussion, I'm going to treat orchestration as a couple of different activities. One is clustering. So orchestration means I can take 5 servers or 50 servers or however many servers, and I can bundle them into one large group of servers that workloads get deployed to. And the way those workloads get deployed and the decisions on how to deploy them is scheduling. Right? It's like, I need this workload to always go on a server that has SSD, or I need this workload to always be deployed on the same server as another workload. So those sort of decisions are scheduling decisions. And so when we talk about orchestration, we talk about clustering and scheduling. So Swarm does that. What we did with 1.12 is we brought Swarm into Docker Engine. So it's no longer a standalone component, right? So the Docker, and there's a couple of things that go along with that, right? If you want to deploy applications, you want to be able to find them, and you want to be able to access them easily, and you want to be able to do that in a secure manner. You want to make sure that everything in that environment the communication channel is secure. So you can see where we've got TLS and certificate authority up there. 1.12 now includes its own certificate authority. It sets up TLS authentication and communication between nodes in the Docker Swarm automatically. We'll do key rotation for you. You can, of course, implement your own CA if you want to do that, and you can, of course, not use the built-in orchestration. You can use classic Swarm or whatever you want to do, but it's there for if you want it. Load balancing and service discovery we'll talk about, and we'll talk about the architecture a little bit more. So let's move forward with that. So we talked about this just now, right? So every node has a cryptographic node identity, and we automatically set up authentication and TLS authentication and key management between all those nodes. And if you've ever done that, you know that it can be a significant amount of work. That happens automatically. To create this Swarm node, the Swarm cluster, you issue a 3-word command, Docker Swarm join or Docker Swarm init, and that's it. And you can do that repeatedly. I'll get into more of that in a few more slides, but we had like we have vExperts for VMware, we have Docker captains for Docker. And we had a Docker captain who went out and said, I want to build the largest Swarm cluster I possibly can. And so what he did was he said, these are my manager nodes, and they live on these IP addresses. Please join my Swarm cluster. And to do that, you just need to have internet connectivity between your machine and his. He built a Swarm cluster, his name's Chanwit. He built a Swarm cluster that was 2,500 nodes and was running nearly 100,000 containers. And he stopped because his monitoring stack failed. He could no longer monitor what was going on, so he had to stop. And people could do that, right? They just Docker join. Of course, there's a lot of security, right? There's ways to set up Swarm with a Swarm manager to say, like, don't let us node join unless I explicitly approve it. There's a bunch of security around how nodes get joined. It's like, in Chanwit's example, he just had the gates wide open, but we have controls around that to make sure that you can ensure that people just don't randomly join your Swarm clusters. Multi-host networking. So both Swarm and our overlay networking previously required the use of an external KV store, which in and of itself is not a bad thing. It just adds one more component that can fail, and it adds one more piece of overhead when you have to scale out. We had done some scalability testing previously, and we found that we would have never got anywhere near 2,500 with an external KV store, right? It just would have been we would have kicked the KV store over. Now we have that KV store integrated into all of the Docker managers. It's a distributed key value store, so it's not centralized. We can then now build out these multi-host networks and have them be much more scalable and much more performant. And I'm kind of speeding through because we're a little bit of a time crunch, but this one is actually really cool. I mean, I think it's cool, but what we do is we have a built-in routing mesh. So if you look at the example on the screen, we've got a swarm cluster there of 4 nodes. We have 1 manager and we have 3 workers. And those 3 workers are hosting a service called front end, and it's been added to the network MyNet. And you can see that by down here on the slide, right? Network MyNet, the name of the service is front end. We have 3 replicas, and we're using port 80 to do that, and we're basing it on the front end image. When a request comes into the manager, right? So you go to like manager IP :80, myapp.80, that request can come into any one of those 3 nodes in there. It can be load balanced from the manager in any one of those 3 nodes, but those nodes have knowledge of where those services run. So where that request comes into worker 2, it's not a problem because the node already, the service is already on worker 2. But what if that request came into worker 3? Well, worker 3, right, because of the routing mesh it has, knows where to find those services and will automatically route the request. So you don't have to worry about where the workloads, where the tasks actually get deployed, because we'll be able to find them wherever they end up. That's the built-in service discovery.
You route or reroute to the correct host?
I don't, like, how are you different?
Does it have to go through worker 3 to get to 2, or you just automatically?
Well, once it goes, well, it points it to, well, I mean, question is like, what is all the traffic then to be going through worker 3? No, I think it basically returns back and says, where you really want to look is here at worker 2.
Right.
And it's not like going to be like this convoluted route. It's going to be like, oh, it's over here, now talk this way, right? Because what you're talking to is a container. It's basically, where do I find the work? Where do I find the task? Where do I find the container? So swarm topology, right? Swarm clusters are made of workers and they're made of managers. And what is a worker and what is a manager? That is defined when you type Docker swarm join. You say you're a worker, you're a manager. That's, it's dynamic, those roles can be changed, it's programmable, right? Meaning we can scale it out. And it's highly available. So because we don't have a centralized store, all the information is stored across all 3 of these swarm managers. There is a leader, right? That's derived through a Raft consensus election. So we use Raft as the algorithm to communicate between those swarm managers. So if one was to fail, right, we would know that. We would have an election, we would get a new leader, and then the traffic would be routed to the containers underneath automatically. And that happens. And we can stand up, depending on the number of managers you stand up, you can survive multiple failures. So in this case, we can survive a single failure. If we had done 5 nodes, we could do 2 failures. The algorithm is like n divided by 2 has to be greater than 1 or something, or greater than.
N over 2 plus 1.
Yeah. It's like there's an algorithm for it, but it's basically divide it in half and be greater than what you have left. So in this case, right, 3 divided by 2 is 1.5, and you have 2 left, and that means you're good. You're golden. All right, so we talked about this a little bit. We have the internal store of information. So all of this information is propagated against the manager, through all the managers, right? Highly convergent, pretty rapid, happens pretty fast. And then in the workers, for them to be able to communicate to each other for that routing mesh, we use gossip, right? So it's eventually convergent. So they know how to talk to each other. They know how to do that networking component. We talked about the quorum layer. The most important thing is that everything is consistent, right? That it's fast and can be secure, right? So that's why we built it the way we did. And then we talked about the workers are not as fast as to be converged, because you're typically going to have a lot more workers. So we say it's eventually consistent. It handles the load balancing rules, the routing mesh. It's peer-to-peer between the workers to be able to do that. So I want to kind of actually get to the demo, so I'm kind of blazing through these things. I'm actually not talking about any of this because this all happens in the demo. I'm going to demo all that. So what we've got for the demo is, we're going to come back over here, and Docker node ls. So this is a 6-node cluster with 3 managers, and one of them is a leader and 3 workers. If I pop over here, back into my web browser, I've got this visualizer that shows you the same thing, right? So you can see that there. So if I come back over and I say Docker service create. So a service is the work you want to do. I need to have a web front end. I need to have a database. I need to have some business logic, right? And a service is made up of tasks, and tasks are made up of 1 or more containers. And I'm going to create a service called web. and I'm just going to deploy Nginx. But I'm going to create it. So that was the service, right? So if I do a Docker service inspect and make it pretty. What? How that? Oh, yeah. I'm rushing, so I'm missing little things like telling it what service to inspect. So there you go. That's one service. There's one replica. If I come over to my visualizer, there's my replica running right there. So sorry, blew through that. Right there's that Nginx image running. So now I want to scale it up. So I say Docker service scale web equals 15. So give me 15 instances of that instance. So if I do that, we'll come over here, and eventually what we'll see here is 15 instances running. So they'll start to pop up over time. They have to pull the image down, and then as they do that, they can start replicating out. So they pull the image, and then they can instantiate the containers, and then you'll see the cluster start to fill up. So what I want to do next is I want to go ahead, and once this happens, I'm going to take one of these worker nodes, and I'm going to put it into what we call drain mode. And because I don't want to fat finger it, I'm going to actually copy it because I'm lazy, and I don't want to have to screw it up. Okay, so pop over here. So I'm going to do, so let's make sure that in my visualizer, so I've got my 15 copies running, right? So I'm going to drain worker 3. It's got 2 nodes on it. So what drain does is it puts it essentially in maintenance mode. It says, flush what it's doing now, don't let it take any more work. The manager still, the node is still up and running, it's just not accepting work. So we do drain worker 1. If I come back over, worker 1 isn't there, and eventually what we're going to see is that those workloads are starting on other nodes. And we do that because that's desired state reconciliation, right? It's basically saying this service knows it needs to have 15 instances running. That's the state of the service. So when I see that it doesn't, I'm going to immediately make sure that that happens again, like that it gets back to that state. And we can scale it down. So where I made it 15, I can do 10, right? And if I come back over, it immediately kills off 5 of those containers, right? Because that's the state of the service. If I bring worker 1 back up, not arcdiv, but active, and I say give me 13 containers, scale it back up, then you'll see that those will end up back on worker 1. Potentially, they could end up actually anywhere. But that's a really quick example of sort of all of this that you've seen is happening using the Docker engine. There's no extra software loaded on it. It's all being done securely, and it's all being done in a high availability fashion. To build this cluster literally would take you 30 seconds to do it. You would be like Docker swarm init, and then you'd issue 5 Docker swarm join commands, and it'd be over and done. If you want to actually see it for yourself and play with it, if you install Docker Machine on your laptops, you have to do Docker Machine, and you go to this repo here. There's a swarm demo, and you can actually run this demo. You can run a couple. There's a setup script that will build the swarm cluster for you, and then you can run through the demo and play with it some more.